In this video, I want to talk about Application Performance Monitoring, or APM. I have made a video on this several years ago, but I figure now is a good time to cover this topic again with a new video series that uses the latest version of Elasticsearch and also speak to new things I have learned since then. I also want to start from the very beginning so that junior programmers without any knowledge of APM can also understand this topic and use it in their careers. I will start the series with 3 episodes. The first episode is an explanation of what application performance monitoring is. I will just present the background, concepts, and definitions. And of course, I will explain how easy it is to use a tool like Elasticsearch to achieve application performance monitoring. In the second episode, I will provide a step-by-step demonstration of how to implement APM for a Node.js application with Elasticsearch. In the third episode, I will provide a step-by-step demonstration of how to implement APM for Python and Golang applications using Docker and Elasticsearch. Then there might be some follow-up videos to cover anything else important that I may have missed. There are also videos for paid members of our YouTube channel for other valuable lessons around APM. You can see on my screen here some of the videos that I have already created at the time of this recording. So consider joining as a paid member if you want these extra lessons. You can also join as a paid member simply to support our channel so that we can continue to produce these kinds of tutorials for you. So let's get started. To understand what application performance monitoring is, we should understand the problem. Let's take a look at this piece of JavaScript code. If you're not a Node.js developer, don't worry, I've got other examples written in Python, PHP, and Golang, which I can demonstrate a little bit later. For now, hopefully this code is straightforward enough for you to understand. This Node.js code serves up a website with 3 URLs. If you visit the home page, which is just a URL ending with the /, the web page will just print the text, "Hello World." If you visit the URL example1, the app will run into an exception or error because this code is trying to access a variable that hasn't been declared yet. In a real-world application, you probably won't have an obvious error like this. In a real application, your error will probably be harder to identify or reproduce. But for now, I'm just going to use this simple error as a substitute for our demonstration. And finally, if you visit the URL example2, the website will print a message, but behind the scenes, the code will make an HTTP request to an external network. So let's say you deploy this piece of code to several servers around the world. You deploy this app to a server in New York, to a server in Lagos, and to a server in Mumbai. And then people around the world start interacting with your app. People in the Americas will connect to the app in New York, people in Europe and Africa will connect to the app in Lagos, and people in Asia will connect to the app in Mumbai. So everything seems great so far. But a few problems could arise. The first problem is, how would you know when your application encounters an error? If someone tries to visit the URL example1, your application will run into an exception because it is trying to work with a variable that hasn't been declared yet. As a developer, you want to be informed of these issues immediately so that you can correct it. Without a monitoring solution, the only way to know about this error is to manually log into each server around the world and review the system logs, and this could be slow and unmanageable. The second problem is, how do you know if parts of your application is not performing the way you expect? For example, if this fetch statement takes too long to execute, how would you know? And this fetch statement could behave differently depending on whether it's being executed in New York or Mumbai. In New York, maybe the fetch statement only takes a few milliseconds to execute, which is very fast. But this same piece of code, when run from Mumbai, could take several seconds to execute, which is really slow. How do you monitor this latency in the different instances of your application deployed around the world? This is where the field of Application Performance Monitoring, or APM, comes in. As the name implies, the goal of APM is to monitor the performance of your application. Here's the definition I pulled from the Elasticsearch website. APM, or Application Performance Monitoring, is the process for organizations to quickly identify and resolve any performance issues in their application and code. APM solutions collect, monitor, and analyze telemetry data from websites, software applications, and services. Teams get end-to-end visibility across their application so that they can understand application and service dependencies and address any errors or slowdowns. APM solutions also store and utilize historical data to surface trends and detect outliers for key performance indicators such as latency and throughput, as well as business KPIs. So that's a high-level definition. In terms of implementing APM, there are many platforms that can do this. We will demonstrate APM with an open source platform called Elasticsearch because that is the tool that we are most familiar with on this channel. But there are other options as well. You may have heard of solutions like Datadog, Splunk, New Relic, and many more. Most of these are offered as paid commercial services. We like working with Elasticsearch because it is open source and lets us host everything on-premise. In any case, the concepts we present in this video will likely translate over to those other platforms as well. So let's continue with this code example. How do we set it up for APM? At a high level, there are a few steps. First, we should aggregate all our performance data for our applications to a single platform. This means we need an APM log service to store all our data. Normally, you would distribute your data store across a few data centers for high availability, fault tolerance, and redundancy. But for this explanation, let's just say we have a single APM log server placed in Berlin, Germany. Second, we need to install an APM agent somewhere. An APM agent is simply a piece of software that will relay performance data from your application to the APM logging server. One method is to install an APM agent on each of your application server so that your application sends data to your APM agent through localhost without any external network requests. Third, we add monitoring code to our Node.js application. We call this process instrumenting our code. For example, this first line enables APM within our application. Once enabled, the APM agent will capture a lot of telemetry data from our application. You can also instrument this part of the code with something called a span. This span will measure the time it takes to execute the code between the span start and the span end. Finally, now that we have all the data shipped to our APM log server, we need a way to review the data. We could read the logs as plain text files, but that can be a bit overwhelming. We could also import the data into a database and use database queries to create text-based summaries or text-based reports. Or we can use a platform like Elasticsearch and Kibana, which offer many features such as data visualization tools to help us understand our performance data through charts and graphs. Elasticsearch and Kibana also gives us tools to set up real-time alerts for KPIs that we need to be aware of. And that essentially is a high-level explanation of how we set up APM. Before we set up APM, we need to go through options available to us for each of the components discussed so far. For the agent that is responsible for shipping our APM data to our APM log server, we have a few options. The first is to use the binary APM agent that the Elasticsearch team offers. This is the simplest method. You just download the APM agent as a binary file onto your application server and run it. The second way is to use something called an Elastic agent, then have the Elastic agent use an APM integration. This method is more complex, and I have an entire series on Elastic agents, agent policies, and fleet servers which discuss all this. In fact, in my very first video series a few years ago, I demonstrated APM through the use of Elastic agents and fleet servers. I plan to update my video series on APM with Elastic agents and fleet servers in the near future. There is also a third option with OpenTelemetry. OpenTelemetry is an open source observability platform offered by the Cloud Native Computing Foundation. It is not maintained by Elasticsearch team, but Elasticsearch's APM framework does support it. I do not know much about OpenTelemetry at this point in time, but if I learn more about it in the future, I can create some videos around it. So going back to just the APM agent and Elastic agent, in terms of how you would choose between these two, I would summarize it like this. An APM agent is designed to capture and ship only APM data, while an Elastic agent can capture and ship much more than just APM data. Elastic agents use integrations to decide what data it can ship. Let me just go to my Elasticsearch instance. So this is my Elasticsearch instance in a dev environment. And if I click on this menu and I go to integrations over here, you can see that there are a lot of integrations over here. APM is just one of the many integrations that an Elastic agent can handle. So if all you care about is just APM data, then stick with the APM agent that I first mentioned. But if you want to ship data for anything else, like Amazon EC2 information on your servers, or Amazon RDS information on your servers, or anyway, there's just so many things here. Azure related data, there's Cisco related data. If you want to ship any of this other information, then you may want to use an Elastic agent. So again, if you want to learn more about Elastic agents, agent policies, and fleet servers, then check out my video series, which I'll put on my screen right over here, and I'll link to it in the description. And if you want to learn how to set up APM with Elastic agents and fleet servers, subscribe to my channel and you'll get a notification on when that new updated version of the APM series on Elastic agents and fleet servers is available. But for this video, we will stick with the APM binary agent approach. Next is the APM Log Server. The APM agent can ship data to either Elasticsearch, Logstash, or Kafka. So let's discuss each of these output options. First, let's talk about Elasticsearch. Elasticsearch is a distributed data store that can do many different things. But for simplicity's sake, you can think of Elasticsearch as a NoSQL database like MongoDB. Kibana is a data visualization platform that works seamlessly with Elasticsearch. So with Elasticsearch and Kibana, you can get nice dashboards for your APM data right out of the box. I will demonstrate this in this video. Another option you can consider is Logstash. You can install Logstash on a server and receive APM data as log files. Logstash is a software offered by the Elasticsearch team that can operate as a standalone service. You can use Logstash to ingest data from the APM agent, perform any optional transformations on that data, and then output the data somewhere else. This web page here shows all the different output options that Logstash can handle. And you can see there's quite a few options here. You can output your APM data as CSV files, you can output it to email, you can output it to Elasticsearch, Datadog. There's just so many different options. I have a whole tutorial on Logstash for those interested in it. Logstash is a very handy and simple tool to use. In this video, I will do a simple and easy to understand demonstration of how to use Logstash as your APM logging server. For our paid members, you can also check out a follow-up video in our members area where I show how you can configure Logstash to output the APM information to another database like MongoDB. And finally, there is Kafka. APM agents can publish data to Kafka. Kafka is a highly efficient tool for producer-consumer architecture. It is suitable for high-volume infrastructures. I will demonstrate this option in a members video for our YouTube members. For instrumentation, you can instrument backend applications written in most popular programming languages. I will have demonstrations for Node.js, Python, and Golang. And for our paid members, I will have a PHP example, and I will also have a real-time user monitoring example for APM of client-side web apps. And finally, for reviewing data, if you were using Elasticsearch and Kibana as your APM log server, you already have your dashboards. If you're using Logstash or Kafka for log servers, then you can build your own data visualization tools. So that's basically an introduction to application performance monitoring. In the next episode, which I will upload shortly, I will do actual demonstration.